What up, little critters? Happy Sunday to y'all. I'm sure you're all studying, being good students. Maybe, I don't know. We'll see. Yeah, so we'll be going over the Unit 7 review. Again, if you guys have any questions, you know that you can type them out. And I know it says Unit 6 on this, but I promise you it is Unit 7. I still haven't figured out how to have YouTube rename the videos before they go live. They just kind of happen and do whatever they want. So hopefully we'll get that worked out. Um, I'll wait a little bit, get people up and running so that if there are any questions, you know, give them all a chance. We'll wait like maybe 2 to 3 minutes, but then we'll just jump in from there. Gotta get the pop out chat because that actually looks cooler. Yeah, cool. Yeah. Had a lot of fun this weekend. I hung out with several friends down in Ventura. I also got to go on a 5 mile hike. That was really fun. First hike I've been on since probably a year before my surgery. So that was probably almost 3 years ago. Yeah, Mr. T, you're slacking. Don't worry, I'll get there. I'll get there eventually. But I guess I'll just go through this entire review and just kind of see, answer all the questions. And then from there, you guys ask questions or do whatever it is you do. But you guys got to work hard. All right. It is currently 4:01 on this lovely Sunday. Now it's 4:02. Like I said, 2 minutes. So here we go. Gonna find the value of our variables in like 99% of these, but gonna make sure we know what all of these shapes are. So right here, see it's a parallelogram. So that means that opposite sides need to be congruent. So these two are congruent, these two are congruent. So therefore I'm going to say 3x minus 5 equals 2x plus 4. And we're going to solve that nice little equation and take away 2x from both sides. And at the same time, I'm going to add 5 because I do what I want. We're going to have x equals 9. Now, do I need to, and the lengths of the sides. Okay, so now we got to plug our variable back into our equations. It doesn't matter if I plug it into the left one or the right one, since those two sides have to be equal. So I'm going to plug it into the right one because I like smaller numbers. 9 times 2 is 18. So then I'm going to have 18 plus 4 equal to 22. So here 22, here 22. When I substitute the 9 up here, 9 plus 6 gives us a nice 15. Sweet. All right. Number 2, we got a kite. Now, unfortunately, the markings were still left on there. I originally meant to have them removed, but only you have two different sets of sides that are congruent to each other. None of them are parallel, and it's not the opposite sides. So we're going to say m plus 3 equals 3m minus 5. And with this right here, we're going to go ahead and solve for m. Got to subtract m from both sides. And then at the same time, I'm going to add 5. So therefore, we're going to have 8 equal to 2m. And then, of course, we got to divide out the lovely 2 in front of the m. So m equals 4. Now, if we plug it back in, we're going to go ahead and have 4 plus 3. So that's going to get us 7 here, 7 here. Again, you could plug it into the 3m minus 5. You don't have to, but again, whatever, as long as you're doing the proper work. Now, I can plug my m back into this other one, except I have a t mixed in there. So let's set up an equation at least and say that m plus 2t equals t plus 9. All right. So we know that that m is equal to 4, so I'm just going to say 4 plus 2t equals t plus 9. Now let's move the t over to the left by subtracting it, and then let's take away 4. So now we're going to have t equals 5. Let's plug in both our m and our t's. Well, actually, we don't have to. We could just take this and plug it in right here. So 5 plus 9 is 14. All right, we're on a roll here. We're getting there. For some reason on YouTube, it normally tells me how many people are watching, and then I go from there, but whatever floats your boat. Even if there's 0 people watching, that's okay. You guys can reference this later. No harm, no foul. All right, the isosceles trapezoid. Since it's isosceles, that means that the legs are congruent. So we're going to say 2x minus 7 equals x plus 1. So then we're going to have x equal to 8. Take that x value, plug it into your side lengths to find their measures. So here, 8 plus 1 gets us a 9. 8 minus 1 gets us a 7. 8 times 2 minus 2. So that's going to give us 16 minus 2, which is 14. And then, of course, since it's isosceles, that's also a 9. All right, we are getting there. The rhombus means all 4 sides are congruent. So boom, 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 boom. So really, you can choose whichever equations you want to work with. I'm going to work with the smaller numbered ones. So right here, I'm going to subtract 3x from both sides, then take away 7. So then we're going to have x equals 2. We'll take that 2, plug it back in. Now, even though I say, yeah, let's deal with smaller numbers, I'm going to plug my x equals 2 into the top part of that, the segment TU, because I'm only going to be subtracting 1 after I multiply it. So 8 times 2 minus 1, so that's 16 minus 1, which is a nice 15 all the way around. All right. Now, number 5, find the values in our parallelograms. Ooh, parallelograms. That means that these are parallel. That means that these are parallel. We're going to have a lot of fun things happen with the diagonals. Great. So let's see here. I believe that since we have our parallelograms, we're going to have alternate interior angles here and here. So then x equals 37 degrees. Let's see here. It looks like angle y and z are congruent. So we're going to have to solve for one of those. Ooh, you know what? I believe if I look at this as a straight line, these two angles together, why am I picking the same color? Let's do red. These two angles together have to add up to 180. So let's do that. 180 minus 63. So that's going to be 117. So that's the measure in the corner here, right? So I'm going to look at this as a triangle, and all 3 angles have to add up to 180 degrees. So 117 plus 37 plus z equals 180. So 154. And so then when we subtract that, z should equal, what is that, 526 degrees. Now, z equals 26 degrees, and so does y. All right, let's keep going. Another parallelogram. So we have a couple options here. I'm looking at these mixed variables, and I'm thinking, not a big fan of them. So we got to figure out how to solve them. Well, what I'm probably going to want to do is I'm probably going to want to use the fact that since I'm dealing with angles inside of my regular parallelogram, I'm going to want to think of some way to create, a relationship between two adjacent angles. So let's see here. We know that we can kind of create our little U-turn here, like I've shown you guys before. So that means they add up to 180 degrees. That's our same side interior angles. So 3y minus 20 plus 4y plus 4 equals 180. So then, combined like terms, we're going to have 7y minus 16 equals 180. wow, that looks definitely not like a 7. 7y, when we add 16 over, we're going to have 196. Does that go in evenly? Huh. Because 7 times... Why am I only having 196 divided by 7? Yeah, 28. Okay, that was weird. I was second guessing myself. All right. Y equals 28. Is that all we have to do? Find the values of the variables. Sweet. So I don't need to plug it in. Although I will probably need to, because another one of our theorems for our parallelograms is that opposite angles are congruent. So we can say 4y plus 4 equals 4x. So we're going to take 4 times 28, add 4 to that, and we're going to solve for x. So let's see here. So that's going to be 3, 9, 12. 112 plus 4. So 116 equals 4x. So then x equals, this is going to be a long 9, 4, 8. So that's the remainder of 3, 9, 29. Alrighty. We're done with the first page. We can move on to the next page. Yet, I believe there's 4 pages. Yeah, 4 pages. We're a quarter of the way done. Find the values of the variables in our parallelogram. So it looks like we're dealing with AE, which is this length here. We've got EC, which is this length here. Now, in a parallelogram, I do know that the diagonals bisect each other. So actually what I can do is I could say, hey, these two are equal. And I'm going to keep the yellow highlighter just so that I know, hey, they're on the same diagonal. Let's see here. We have these two that are given to us. So again, the diagonals bisect each other. So those two are set equal. So let's see here. We've got 4x minus 2 equals 3y plus 1 minus 1. Can't do anything with that one, so let's try the other one. 3y minus 3 equals 3x. Oh no. I got a bunch of mixed variables. That's okay, Mr. T, because all you got to do is solve for one of the variables. And I believe this equation is going to solve out nicely for us. So we're going to have y minus 1 is equal to x. Well, guess what? Now that we know what x is, we can substitute it right in here. Yeah. So let's do that. So 4 times the quantity of y minus 1 minus 2 equals 3y minus 1. Yeah. So then distributing 4y minus 4 minus 2 equals 3y minus 1. Now from here, combine like terms, 4y minus 6 equals 3y minus 1. Ooh, this is going to turn out nice. So I'm going to add 6 to both sides. I'm going to subtract 3y from both sides. And so we're going to have a nice y equals 5. Now that I know y, plug it back in here to get x. So 5 minus 1 is the value of x, or x equals 4. Sweet. All right. Now, are the quadrilaterals below parallelograms? If yes, explain why. Let's pretend that the directions also say, if not, explain why not. Okay, like we could explain, because you're probably going to have to be able to do that, right? You need to be able to justify why it doesn't work. So for 8, I'm looking at my markings, and what it's telling me here is that this and this are congruent, this and this are congruent. So it looks like the diagonals are bisecting each other. So we're going to go ahead and look in our notes, I believe the 7.5 notes, and you'll see that this is exactly what's shown in one of the 5 reasons that, or ways to show that a quadrilateral is a parallelogram. So what we'd say here is yes, if, and again, this is the if then statement, right? If diagonals bisect each other, comma, then the quadrilateral is a parallelogram. Number 9. Looking at this, I see these markings match up with these. This marking matches up with this one. They are opposite each other. They are across from each other. And I believe that one is indeed one of our 5 different ways to show. So we're going to say yes, comma, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Sweet. Looking good. Let me fix that last letter. Number 10, I do see that I have these angles congruent and this angle congruent to this one. Now, I do have the diagonals meeting, forming these angles. However, these don't show that the lines are parallel because all these are vertical angles. You really have vertical angles anytime 2 lines intersect. So this is not a definite way of showing that we have a parallelogram. So I'm going to say no. In terms of a reasoning, I have a couple different ways of saying this, but the strongest way I'm going to say, or that I know that for a fact that this won't work, I can say vertical angles. And let me move this over to get more room. Are not sufficient. Or we could say not enough. I can spell. There we go. Not enough info. number 11, I have 4 congruent sides. So technically, I do have a rhombus. And by definition, a rhombus is a parallelogram. But that's not one of our 5 statements, right? We have to make it using one of our 5 statements. So here's what we could say. One of the things we note is that the opposite sides, both pairs need to be congruent. Now, even though all 4 of them are congruent to each other, that's okay because it's still the opposite pairs. So for this one, I can say yes, comma, if both pairs, and let me scooch it over, both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. All right, find the measures of the numbered angles. Okay, I know that this shape is a rectangle. Since it's a rectangle, I know that there are better be right angles at each of those corners. So I know that I'm going to have to use 90 degrees when it comes to angles 2 and 3. Now, angle 1 forms a straight line with 56 degrees. So that means that the 2 angles must add up to 180 degrees. So far, so good. So 180 minus 56 is equal to angle 1. The measure of it, so angle 1 is going to equal 24 degrees. Yay. Now, angle 3 and angle 2, I'm going to find in the same manner, but depending on which one you solve, you're going to use a different angle as part of it. So in a rectangle, the diagonals do not only bisect each other, but they're also all congruent to each other. So we create these 4 little segments. I'm going to work with the 56 degrees. So I'm going to look at this triangle. And if I recall, when I have a triangle that has 2 markings that are congruent, that means it's isosceles. That means that angle 3 is going to be congruent there and in this little corner here. So I'm going to say that angle 3 plus angle 3, right, if we're being technical here, plus 56 adds up to 180 degrees. So when we already kind of did that already. We took 180 away from 56 earlier, or 56 away from 180. We ended up getting, oh my goodness, why did I say 24? Wow, Mr. T, you're tight. Let's try 124. All right, so I'm going to take these 2 angle 3s, and because there are 2 of them, I'm going to say 2 angle 3s. You know what? Yeah, why not? 2 angle 3s equals 124 degrees. Now, to get the value of just one of those angles, just divide by 2. So angle 3 is going to equal 62 degrees. So then angle 2 plus that 62 forms a right angle. So I'm going to say 90 degrees minus the 62 equals angle 2. So that's going to be 28. Nice. 1, angle 2, angle 3. Sweet. All right. 13. Got a rhombus. And in a rhombus, I know that each diagonal bisects its respective corner into equal pieces. So those 4 angles are going to be congruent. Right over here, these 4 angles will be congruent. And one more fact, the diagonals of a rhombus always form a right angle. So that means angle 2, without doing any work, 90 degrees. Also, without doing any work, angle 1 is 60 degrees. So angle 1 is 60 degrees. Angle 2 is 90 degrees. I don't need work for angle 4 because that's also in the same spot as angle 1 and 60, so that's 60 degrees. Angle 3 is really the only one we have to do work for, and even then it's nothing new because take a look at a triangle. And again, all the angles in a triangle must add up to 180. So here we go. Oh, how nice. If you noticed, we already had 60 degrees, and we already had the 90, so I believe this is going to be a 30, 60, 90 triangle. So angle 3 is our missing 30 degrees. It's all good, Eob. Wait, what do you mean tune? Oh, tune conveyed. Huh, I was going to say. All right, so number 5, Eob, I'll go back to that one real quick before I resume. Hopefully that'll be of help to you. Just give me a nice confirmation that you got it or ask any questions about it, okay? Do 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 do. Thanks, just wanted to make sure the work was good. Awesome. Okay, so let's move on. So, see here, I'm on number 14 now. So in a kite, the diagonals don't all bisect each other, just the long diagonal does. So what's going to happen is that this diagonal is going to cut these into equal pieces, and then these angles will be different measures. Now we've got a couple of triangles to work with, but we also have again that the diagonals form right angles. So right away, angle 1 equals 90 degrees. Okay. Angles 3 and 2 are in two separate triangles. So I'm going to designate this one as the green triangle and this one as the blue triangle. Okay, that does not help if the yellow highlighter is there. Let's kind of get rid of it for a second. There we go. Okay, so you know what? Galaxy it up. Nah, that's too nice. There we go. Okay, so looking at the blue triangle, I have the 90 degrees and the 35. Add that to angle 3, they add up to 180 degrees. So when you get angle 3 by itself, you should get a nice 55 degrees. Angle 2, we're going to do the same thing. Even though I didn't mark it on the figure where those diagonals are, that is still a right angle. Still got one here, still got one here. So again, 90 plus 65 plus angle 2. That is definitely not a 2. So then angle 2 is simply going to give us 25 degrees. All right. That is so far this page. We got 2 more. Shouldn't take us more than probably 30 minutes if I just kind of go through it. But again, if you guys have questions, don't hesitate to ask. If you're watching this later, sorry. I guess you could ask me questions on Remind. Whatever works for you. I know some of you guys don't use it anyway, so that's all I need. All right. So let's see here. A, B, C, D, got a rectangle. So let's draw the rectangle. All right, so AC, which is my first diagonal here. Okay, first off, there we go. So that's going to be 3x plus 12. And then BD is 5x minus 6. So the diagonals must be congruent, so we're going to set them equal to each other. So let's take away 3x and then add 6. And then lastly, divide by 2. So x equals 9. Yay! We solved for x. Now let's plug it back in. Find the length of our diagonal. So doesn't matter which one. I'll plug it into the 3x. 3x plus, oh wow, 3x. We know what x is, guys. It's 9. Yay! Plus 12. 9, 18, 27 plus 12, 39. Find the length of each diagonal. They're both going to be the same, so we would say AC equals 39, BD equals 39 as well. Alrighty. Number 16, got ourselves this isosceles trapezoid again. Angle P is 125. Find the measure of the other angles. All right. Again, since it is isosceles, that means that your base angles are going to be congruent, as well as these top angles here. So this angle here is 125. This is also 125. Now, to make our lives easier, I don't want to deal with this as a quadrilateral. Instead, I want to deal with the part that's dealing with the parallel sides, because we'll be doing less work. And I know how lazy you guys are. Cool. The reason I'm looking at those is because I'm thinking, hey, this creates our little U-turn. That means all three. Wow. That means that those two angles that are next to each other need to add up to 180 degrees. So let's say angle S plus 125 equals 180. So then that should be angle S equals 55 degrees. So this is 55. This is also 55. Again, another isosceles trapezoid. Ooh, PR. So PR is this. QS is that. Hmm. Hopefully, if you guys noticed, it does say that the well, trapezoid is isosceles. So that means our diagonals are congruent. So we're going to say 5y minus 8 equals 27. All right. So there's our value. Find the value of the missing sides in our kite. Let's see here. I'm given an angle. I know one of the parts. Wait a second. I treat this as a triangle, and I know a kite forms a right angle at the diagonals. That means we're dealing with a special right triangle here. Now, technically, you could use trig here, right? Technically, you could. I'm going to do the special right triangles because I'm going to want the exact value. So my 30 degrees is pointing to y, which is the short leg. X is the hypotenuse, and we have the long leg. So let's just do some work. Long leg is equal to short leg times rad 3. So 14 equals y rad 3. Got to divide out the rad 3 from both sides. I need to get that radical out from the bottom there. So I'm going to multiply top and bottom by the square root of 3. These two multiply to make a plain old 3. And then the 14 and rad 3 just multiply. Now, if I'm able to reduce this fraction, I'm going to reduce the 14 and the 3. However, nothing can do that, so we leave it be. Now for x is the hypotenuse, so my hypotenuse is equal to 2 times the short leg. We literally just calculated the short leg, so let's go ahead and just substitute that in. So x equals 2 times 14 rad 3 over 3. Now, if you remember when you multiply a whole number with a fraction, you don't multiply the denominator with the number, just the numerator. And specifically, we're going to do 2 times 14. And there you have it. So for 19, we again have what appears to be a special right triangle there. So that means that our legs are going to be congruent. So that means that y equals 5. No assembly required. Batteries not included. However, we are going to need to solve for x. So x is our hypotenuse. And in a 45, 45, 90, the hypotenuse is equal to the leg times rad 2. So x is just going to equal 5 rad 2. Literally minimal work needed. Alrighty. We're on the last page. Yay! 5 more problems. Solve for x. Well, it is a rhombus. So that means that these two angles are congruent with these two. These two angles are congruent with these two. Oh, and in a rhombus, the diagonals form a right angle. Ah, you know what's going to be nice here? Is if we could move this 2x minus 5 to right here. You are being disrespected. Only 2 people are. Well, it's fine, Eob. It's early on, and you know what? Like I said, at this point, there's no reason for me to be upset. I'm actually happy that there are 2 people. It's totally fine. So let's see here. We've got 2x minus 5 plus 7x minus 4 plus that right angle. Do not forget the right angle. That's going to add up to 180, yo. My 2 does not look like a 2. We should fix that. There we go. I'm going to combine the 2x and the 7x. I'm going to combine the negative 5, the negative 4, and the positive 90. So that looks like negative 9 plus 90. So I believe that's 81. Negative. All right, so we're going to add 81 to both sides. 9x equals 261. So I know that 9 goes into 26 twice, right? 9, 18. If I try 27, it goes over by 1. So 9, 18. So that's another 8, right? I believe that's 29. Although, why do I feel like I'm way off? Yeah, no, that's right. That's correct. 29. Thank you, Eob. You're my boy. You're paying attention, and that's good. Okay, cool. So now solve for x. That's all we have to do. Solve for x and y. It is a rhombus. In a rhombus, all four sides are equal. So can't exactly mix variables here. So let's solve for x first. So let's take away 4x, and then let's add 5. So then we're going to have x equal to 12. Now, we're going to take this x equals 12, plug it into any one of our sides. So 4 times 12 plus 7. So I'm going to have 48 plus 7. So I believe that's 55. So I'm going to say 5y is equal to 55. So y should equal 11. See here, 22. We have an isosceles trapezoid. So again, because it is isosceles, that means that these two sides are congruent. Now, these angles that are formed here, this angle here and this angle here, because it's a trapezoid, and because we have this mid segment here, we know that they're going to be parallel. So that means that they're going to share the same angle. So 5y equals 2y plus 18. And then we're going to divide out the 3. So therefore y equals 6. For x, I'm going to be working with the mid-segment formula. So writing it down, the mid-segment equals 1/2 base 1 plus base 2. Now my mid-segment is 10. So 10 equals 1/2 my base 1, which is x, my base 2, which is 2x, minus 19. Now, if you switch the order of that, it's not going to change the value. If you said your base 1 was the bottom, that's totally fine. If you said the base 1 was the top, again, it'll all work out because it is the commutative property of addition. So we're going to have 3x minus 19 in the parentheses. Now, I got to get x by itself. I could try to distribute the 1/2. That's just going to make a really weird fraction with the 19. So instead, I'm going to multiply both sides by 2 to, get rid of that 1/2. So 20 is equal to 3x minus 19. So we're going to have 39 equal to 3x, and then divide out the 3. All right, got x and y, no z, and that's okay. No z required. Looks like for 23, we're going to do another mid-segment. So then we're going to have 8 equals 1/2 2x plus 5 plus 4x minus 7. So 8 equals 1/2 of 6x minus 2. Now, since the numbers here are all divisible by 2, it's not going to hurt you to distribute the 1/2. So 1/2 of 6 is 3. 1/2 of 2 is 1. So then just a nice simple arithmetic. 9 is equal to 3x. Divide both sides by 3. So then x equals 3. Last, but most certainly not least, we've got number 24. Find the value of x and y in the isosceles trapezoid. So again, since it's isosceles, I know that these top two angles are congruent. These bottom angles are congruent, but I don't have enough information for that part. And that's okay. So let's solve for y first. So we're going to divide out the 5s. So we'll have y equals 9. Now, since y equals 9, I also know that, well, not since then. Let me rephrase that. So since we know that the top right corner was 45, that means the top left corner is going to also be 45. Now, if I treat this again as the parallel lines cut by the transversal, I'm going to have my little U-turn thing that we do. So that means that that corner of 45 degrees plus the 3x needs to add up to 180. So let's get right to it. All right, so if I'm dividing both sides by 3, again, I'm doing this in my head, no calculator here. So 3 goes into 13 4 times without going over. There's a remainder of 1. So that 1 goes with the 5, so it becomes a 15. So 15 divided by 3 is 5. So we get 45. And that's it. That's the entire review. Thank you, Yob. I like that you're participating. All right. So at this point, there's not much more I need to do necessarily. Eob's basically been the only person here. Now, Eob, here's some spoilers, okay? The second viewer of this video is actually myself. I have to have the video running in the background while I'm running the chat. That's just the only way I can do it. So, yeah, you're the lucky winner. Woohoo. If you guys have any questions, just come into the classroom tomorrow morning during tutorial. I'll do the best I can to help you guys, but hopefully you guys watch this video and hopefully it helps you with it. All right? Have a good night, Eob, and everyone else. See you tomorrow.